Hello and welcome to Technical Utkranti. In the previous video, we discussed the scope of variables and functions, what are register variables, and how to have the control flow using goto statements. In this video, we'll see various aspects of input and output in C program. What is the role of input buffer during input output with the peripherals or with the file? We'll understand printf function and various other functions or commands in detail. We'll see different ways of taking inputs and sending the output. By the end of this video, you should be able to visualize and be confident with the input and output using C programming language. So let's get started. You can see buffer over here. This is nothing but memory where the data resides when it is transferring from a program to the peripheral or from the peripheral to the program. Let me give an analogy. Just like there is RAM provided for storing variables and instructions of the program, and the processor interacts with this RAM to get hold of this data. Similarly, buffer is the memory created to facilitate input and output. This region of memory is utilized by standard libraries to store input and output streams of data. Program instruction for read and write interact with the input-output streams present in the buffer. The external peripherals like keyboard, mouse, etc. interact with buffer to get the data. So buffer serves as an intermediary between our C program and the peripherals. I hope you are able to visualize the data flow during input and output. Let's move ahead. Now, coming to specific instructions, we will explore printf a little bit in detail. Printf writes on the output stream in the buffer. The command allows certain configuration to be made which can change the way the output is presented on the peripheral like monitor. Let's see them one by one. Firstly, we'll see type. So type depends on the data type which you are wanting to print on the monitor. For example, D is for integer, F is for float, S is for string, and so on. You can look on the internet to have the complete list of various format specifiers used with the printf function for different types of data. Coming to the precision, precision is used to indicate how many digits are required to be printed after the decimal point. For example, %.2f with 1.414 will only print 1.41, whereas %0f after 1.414 will not have any decimal digit. Same applies with string as well. Now we'll see width and flags with the printf function. Width tells what should be the width of the output printed on the monitor. If width is specified by the user is less than the length of the number, then the number is printed as it is. For example, here we are saying 0D, but the number is 23, so 23 itself is printed. But if the width is larger than the length of the number, then it is prefixed by the space. Space here is shown by the character capital V. Along with width specifier in the printf function, you can also have flag specifier. For example, 04D would say that the width of the printed uh, number would be 4, and instead of space there will be 0 as a prefix. Similarly, the minus sign indicates that the space would be not prefixed but suffixed. So it would be like 2 and then suffix of 3 spaces, then this is string high. I hope printf function is clear. These flags with precision and type are very exhaustively asked in competitive coding examination of companies. Moving ahead, we'll see scanf. Scanf reads the data from the input stream, just like printf writes the data on the output stream. It is the input side counterpart of the printf. As you can see, we have to give the argument as the address of the variable, and on this address the data from the input stream comes and resides. So that is the specification of the scanf command or scanf function. Moving ahead, let's understand sprintf followed by scanf. As of now, we have seen the printf and scanf commands. What did they do? They write and read on the output and input stream respectively, which means that they are dealing with input and output stream of data. Whereas sprintf and scanf will be dealing with the string. Reading from the string is will be done by scanf, and writing to the string will be done by sprintf. As you can see in this code snippet over here, I have created a character array which is nothing but string, and then I am storing this particular string into this string or this character array, right? So if you have to write to the string, then you can use as printf function. This is the output when I print the buffer over here. I mean buffer as in string data, right? Now let's look at the scanf also quickly. So I have this string declared over here, and I have two other empty strings, and using scanf I can read the string declared over here and fill in these two strings, right? As you can see, I have hello and world as two separate strings printed over here when I am printing read1 and read2. So that's how you read and write on the string or to the string. Moving ahead, till now we have seen how to read write from the input output stream, how to read write from the string, and now we'll see how to read write using a file. Let's look at some code. So fopen is the command which is able to read the files directly and create a file stream, file pointer, right? Just like input and output stream, there is file stream. So this over here is represented by the this particular variable. Okay, so once we have this file stream ready, it could be used by various other functions to either capture data from it, read data from it, or write data to it. And as we read and write on this file pointer, we end up updating. In case of write, we end up updating the file itself. Let's move ahead. Okay, and after we have performed all the operations on this file stream, we close this file stream using this particular instruction fclose. So let's see some instructions that are there to deal with this file stream. So fgetc and fgetS, these instructions are used to get the input from the file stream, and fputs, fprintf, These are some of the instructions to write the data on the file stream. I have given this illustration which you can try out for yourself. Over here, what I am doing is I am creating a file sample.txt which is converted to a file pointer. Now, on this file pointer, I am writing two strings using fprintf and one string using fputs. Note that there is slight difference in the syntax of two functions. Here we have to specify the format, the data type, but here we don't have to because S is kind of indicator that we are writing string only, whereas fprintf can be used with all the other data types. And then finally, we are closing the file pointer. Let's see what happens if we run this program. So as you can see, the sample.txt file is created, and this is because of fprintf, and this is because of fputs. So we were able to write to the file stream and subsequently to the file pointer. To read something from the file stream or file, we have these instructions, and I suggest you to try it out for yourself. Just over here, the format over here we had W, which means we are writing to the file. You can use R if you want to read from the file. Moving ahead, we have command line inputs. Again, we have seen the input output from the input and output stream in the buffer. We have seen input and output using string. We have seen input and output using file. And now we are seeing input and output using command line inputs. How do we do that? So this format of main function you might have seen earlier also, int argc and int argv. I have written it down in comment. Argc is the argument count and argv is the argument vector. Argument vector as in it will hold all the inputs given during the execution of the executable. So I will just quickly demonstrate what I am trying to do. These are the number of arguments, so I'll run a loop over this and then I'll print each argument from the argument vector. Let's see what I am trying to tell. Let's compile this. Now I run this particular thing and I give some arguments 1, 2 and 3. Now let's see what happens. As you can see, it is printing the command which is executing. So this is also one of the arguments, the command for executing the binary, and then 1, 2 and 3, right? So this argument vector holds all the inputs that are there and argc holds the number of inputs which is 4, right? I hope it is clear to you how to take inputs from the command line as well. This brings us to the end of our lecture for today. In the next video, we'll finally have a look at pointers and memory addressing. Do tighten your seat belts for the exciting journey ahead. Hit like as it motivates me to make more videos. Thank you. Good night. Bye bye.